You're watching The New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show. Hey everyone, welcome to a new episode of The New Stack Makers. I am so excited for our discussion today. So what are we talking about today? Well, enterprise AI is like that ultimate data project. I'm sure a lot of you out there know this very well. Technologists once spent most of their time working on data projects that required hundreds of hours to clean up the data. Today, that remains very true with bad data and how it affects AI deployments. And my guest today is Rahul Auradkar, who is Salesforce Executive Vice President and General Manager of Data Cloud at Salesforce. He's here to talk to us about what Salesforce is learning about unifying data in the enterprise to support their customers' ongoing AI adoption. Thank you so much for joining us today here, Rahul.
Absolutely. Thank you for having me on your podcast. I'm delighted to be here. Happy to share my experiences and also learn from you along the way.
Well, we will learn a lot here. I'm very interested in your own background. You've had a long career as a technologist. You grew up in India, you studied there, you moved to the United States, you went to the University of Michigan. That's just a lot in itself. You worked at Microsoft for 12 years. You worked for several other companies in the meantime, and now you're at Salesforce. And I was thinking about, how I reflect on data and how I recall my experiences in using data, you know, many years ago. I remember seeing, wait, these recommendations are all wrong that I'm getting. This is incorrect. And I'm curious about your work as a technologist and those reflections that you have about working with data and what you saw and what was insightful to you in those early days of your career or even, in your education.
Yeah, it's interesting. If I think about it, if I go back to thanks for the background, by the way. Yes, I did grow up in India, and growing up in India, I was an ardent, even now I am an ardent sports fan. I grew up playing cricket, a game very popular in India and Britain and Australia and other places. I also followed the game quite a bit as well. And growing up, thinking about data, right? Growing up, I followed the game through. I was a voracious reader of newspapers and magazines, and also listener of radio and television, and that's how I followed the game. And I did a lot of conversations with people. But then, on the foundation to all of that was I used to have all of these conversations with people about the game and the players, their uh, their averages, their scores. It's a very, very highly statistically intensive game. Uh, and always I found myself answering questions which were grounded in some data, but not all data, grounded in some facts, but not all facts. So it used to be very subjective. So over time, I started to look at uh, data that comes from various different sources. The key here is not about whether the data is right. This When you talk about good or bad data really comes in many different forms, right? Is it complete? Is it of high quality, high fidelity? Is it been summarized in a manner in which it's meaningful for the topic at hand, right? So if I sit here today, in 35 years, 40 years after that, and I reflect back on those days, I look at it as in saying I was doing that, all of that, and we were doing all of that mentally, as in filling in the gaps, unlocking data that is sitting in newspapers, in radio, what we heard on radio, what you see and saw on matches and games, then kind of bringing context to it. What does bringing context mean? You really want to have some normalized schemas. Talk about in today's parlance, we talk about normalized schemas, but the idea is to make sense out of it through some normalized ways in which you can connect it to conversations that you and I can have. So, and if I look back today, if I look at it today, if I look back, the amount of effort I spent in bringing together all of those different facets of data, whether it is newspapers, that's in today's form we call it unstructured data, but in other forms, in real stats, etc. I was a voracious consumer of those numbers, but I told stories using that. And if I reflect back upon it, I would say, wow, it's so different today relative to those days.
That's really interesting. And that gets me to my question about bad data. And what what does bad data look like? I think you answered that question a bit when you talked about context. For me, bad data is in very much tied with the experience. And if the data is inaccurate, that ruins your experience. You're less likely, I think, to rely on that data. I think that's one reason why I love to read the sports page as a kid, because I could read the box scores for, I was a baseball fan, and I could look at the batting averages of the top hitters and on and on and on. But if that data was incorrect just once, I would be done. And today it seems like with AI, we face a whole nother realm of challenges with bad data changing the experience, and it's a different kind of experience. Now it's like, wait a second, we're reading often about all these weird hallucinations that are happening, databases being deleted. And I just wonder about that bad data story and how you see it today.
It's interesting you bring up the idea about bad data and in the context of AI, right? What you've all said and done, at the end of the day, what AI is doing is it's driving intelligent automation and doing that at scale. Now, if you just replace an AI, whatever the AI piece of software is or an agent is, if you replace that with a human, right? You and I go through a lot of pieces of data. For example, a customer service rep in a CRM instance or an account executive in a sales instance is looking at some aspects of data that is informing their business decisions they're making on behalf of their customers. Or you and I are looking at our credit card statement and we're looking up the bank's website and we're making some decisions. Now, when you and I do that, there's a little bit of latitude because there are humans involved. You make some decisions, you probably take a pause. But when you start doing what AI does, which is intelligent automation and intelligent automation at scale, then what gets lost along the way is that if there is high, the fidelity of the data is not high, it's not accurate, then it gets lost in the shuffle. Then the downstream implications of the automation are profound if you get it wrong. Not only profound in terms of accuracy, getting it wrong, also in some cases you might get it wrong with trust being violated as well, right? It's about accuracy, it's about relevance, it's about trust, and those things really become all the more important when you're trying to automate at scale that you don't control as a human.
I'm wondering then where you see engineering teams getting it wrong in the execution. I mean, engineers have the best of intentions, right? You know, but what have you seen them execute that leads to costly tech debt, for instance, and insufficient, unusable data? What are some of the mistakes that they make that you could provide tips for people out there who are trying to figure out, well, what should I not do?
So I wouldn't say engineering mistakes. Let me just take a step back in terms of if you look at it from the lenses of the evolution of where we are today, and it continues to evolve. As a matter of fact, it evolves much faster now than it ever did. Just from a data standpoint, if you harken back maybe 20, 30 years back, you had structured applications that use structured data, forms on data type structured applications where you really access some data, you did something with it, you stored it back, and that's how automation was being driven. And what was really powering it in the back end was a data repository called as a database, and that was structured data. It was essentially a relational store. And then over time, people start saying, wait, that relational store has so much data associated with the transactional set of things that I was doing using my applications. I need to take that out and analyze it. And that's how things like warehouses were born, right? Warehouses were analyzing structured data on which you drove analytics. The analytics over time started being fed back into business processes to say, hey, my descriptive analytics or my analytics that I discovered, if you may, while looking at the data here through analytics that I was running in warehouses, help me improve performance of business in a certain region or a certain aspect of my business. And so I went in and changed my business processes. So that cycle was analytics. Data was an exhaust, and that exhaust was being used to analyze. That analysis was being used to help improve businesses. Over time, then as you evolve, then they said, wait, I can take a snapshot of that data and also and start training these machine learning models that allow you to do predictions, allow you to do some sort of extrapolation, if you may, outside of the data set that exists in there. That's how machine learning, or what I refer to as the old AI, or the boring AI, or the predictive AI, was born. Right now, what has happened over a period of time is that whole paradigm has now accelerated to the point where we're saying, wait, those applications in themselves don't need to treat the data that they create as exhaust, but instead that exhaust itself becomes the way in which we define the applications. That's where all of this generative AI came in. As in, I know something about Rahul. I know a lot about what Rahul has done in my system. I know about his footprint on what websites he has gone. Is my first party data, as in I'm a business. And Rahul has come in through mobile applications, variety of, I know his footprint. Using a footprint, can I really tailor, this is also known as personalization, but can I tailor the business processes along the way? The reason I'm thinking that we should look at it from the lenses of that is, along the way, what was born? What was born was databases, warehouses, data lakes, lake houses. All of these were born along the way. Lake houses were born because you wanted to get the best of warehouses, and data lakes, which really took unstructured data into account. Now, all of those ended up having their own storage protocols, their own table constructs, their own file constructs, their own query protocols. Even SQL as a language, SQL as a language, has its own SQL variant, whether it is done by Oracle or by Microsoft, right? So that's how the debt got created, if you may. These silos got created, and these silos have a lot of trapped data in there. And how do you untrap it seamlessly so that it can be used for meaningful interactions for businesses in their business applications? That problem remains unsolved. And that's what we are looking to solve, or we are very far along at Salesforce with Data Cloud and what we're doing with Agentforce.
Okay, let's get into a little bit about unified data and what you mean when you talk about unified data. And in particular, how does that relate to agentic AI? We're doing a live stream every week called the New Stack Agents, and agentic AI is so popular on the New Stack. We are getting so much interest in the topic. And I don't know much about how unified data relates to agentic AI. So perhaps you could provide us with some context about your view of unified data and your view of unified data and how it relates to agentic AI.
Yeah, so unified data, harmonized data, those are the phrases that I used interchangeably. They do mean different things, harmonization and unification. Let me explain a little bit about it. The previously I talked about warehouses, lake houses, lakes, databases. There is data sitting in all of these silos. When we talk about what we do with Data Cloud and Agentforce at Salesforce, we're not talking about replacing the silos. The silos have a lot of gravity in them, data gravity, as in that's what many of these vendors really are driving. What we're talking about is, how do you bring that data to life in a fluid manner, data fluidity, if you may, that's harmonized and unified. Now, why is that necessary? As an example, if you go to help.salesforce.com now, that is agent first experience that we are driving. If you go ask a question in there, as in, does Data Cloud have an SAP connector? You will find that answer there much richer than what you would get in Google or ChatGPT. If you ask a question as in, can you show me the setup for the Data Cloud SAP connector, you'll get a fairly detailed answer there. Why is that possible? That's possible because we have hundreds of thousands of unstructured textual data that we have ingested, we have vectorized and made it available when your agent is asking that question, or you're asking that question that the agent is helping you with. Now, connect that with structured data. Now, let me use a structured data example. An example of that would be, You have a customer service representative, a human working alongside an agent. The human has their, in this case, the customer service representative has their his or her own agent. You're asking a question of that agent saying, "Tell me Rahul's credit score," because I'm asking a question of that of another my another customer facing agent. I'm asking, saying, "Hey, I want to get a credit raise." So the customer service rep is in turn asking a question to his or her own agent, which is internal to the bank employee. Should this person's a bank employee, asking a question saying, "Can you give me Rahul's credit score? Can we?" And you get the credit score. Then you say, "Can you give me the criteria by which I need to raise the credit limit?" Now it's going into unstructured data and getting that criteria. Why is the unified data matters here? It's harmonized and unified. What's harmonization and unification here? You have data of all the transactions Rahul has done on this credit card over the last that many whatever period of time, that, and it's sitting in a warehouse somewhere. You're bringing that data in real time in a fluid manner and combining it with Rahul's profile, and then you're connecting it with some criteria that the AI agent is giving to the human agent, as in saying, this is a criteria. If Rahul's credit score exceeds X, which is maybe 700 or 750, whatever the number is, and then if this is what the transaction history looks like, here is the criteria by which you would raise this credit limit. Now, that harmonized unified data is coming from, perhaps it might be coming from S3 in AWS, the unstructured data. It might be coming from Google Files, all of the information that is related to some criteria that is stored locally, maybe, or it's coming from Snowflake, all your transaction history. You're bringing all of that, you're harmonizing it, meaning you're creating a consistent schema of what does a credit card mean, what does Rahul as an individual mean, what does a contact mean, what does a credit card mean. You're harmonizing it to that schema, and then you're unifying it, because Rahul might be using a credit, he might be using his cell number to come through one mode. Through another modality, Rahul is coming in through his email address. There are two different modes now. You're unifying the same Rahul now. So its harmonization is different from unification. Then you're deriving an insight. An insight could be, hey, the last 10 transactions that happened with Rahul is paid up in time. There's no problem with his history at all. Then I start looking at 100 transactions. He's missed 14 of them. There's a problem, right? So you're driving insights. Now, using those insights, that system is now giving some guidance to, should I or should I not raise credit limit? Then the human is making the decision at the last minute to give the credit card raise. So bringing it back to what you were saying, if, for example, that swivel chair exercise, this human would have had to go and log into another system, take a look at all the transactions, log into another system, take a look at the criteria by which I raise credit limit, log to another system, take a look at my credit score. That human now becomes that much more productive because data is so much richer, it is fuller, it's complete, it's harmonized, it's unified, it's available to the agent, it's available to the human. The agent is then making recommendations. The human is either taking the recommendation or overriding the recommendation, but it makes the human that much more productive, and the agents are that much more relevant, and they are that much more precise when they're answering the question.
So this all goes back to the idea of a silo, right? First of all, in the enterprise. And the other part is the individual whose data we're looking at, right? Like a lot of things, I expect identity management is changing a lot now with these new capabilities. Do you see that?
Yes. So first off, you referred to identity management. I'd elevate it to access. I'll elevate it to trust. I'll elevate it to governance, to security. So when you start looking at agents, by definition, some of these powerful LLMs are really set up in which they can get access to as much data as they possibly can get access to. That's by design. That's a feature. That's not a bug. But from a standpoint of it being relevant to enterprises who really care about their brand name, they care about security, they care about providing the right experience to customers, they care about data governance. Now, I keep referring to data. It's about harmonized, unified, first party data that is reliable, but the more important thing is it's trusted. That in meaningful manner in which the agent will get access to only the data that the policy that is defined by the business and How do you go enforce that data governance? Right? Recently, we just at Salesforce we GA'd a data governance offering inside of Data Cloud. The way that works is that you automatically tag a data, whether it's structured or unstructured, within chunks. You can tag them, whether it's PII or PCI, or it has a social security number, or it's external or internal, etc. You tag them, and because data is happening at 10x, 100x, 1000x more scale now than it ever did a couple decades back, we're doing that in an automated fashion. Once you finish tagging, then we define policies. The policies also could be default policies, but they also be human driven policies, as in saying anything that is PII driven, nobody gets access except by exception. And then you enforce that during runtime with this thing known as attribute based access control. You enforce those policies for an agent or for a human. So that now is available across structured and unstructured data. I like to say that we went slow to go fast because we wanted to make sure that we deliver trusted data for trusted agents. And we have that now available, and it's table stakes, and also it's a differentiator as well. It's table stakes for businesses to have trusted AI, but having trusted AI to be delivered at the right performance at the right scale is also a differentiator. We are taking a lot of good. We've started maybe about 2 years back in delivering trusted generative AI. We have gone slow to go fast. We delivered again in GA the data governance capability that I just referred to.
When you're looking at your existing architecture, I mean, you recently acquired Informatica, and that's a big part of this unified data story. Um, but Informatica, it's interesting to look at companies like Informatica, and they're still very relevant, right? They're 30 years old, but the architecture is 30 years old. H- How does generative AI help you work with that architecture and then also integrating it with your own cloud native architecture?
Yeah, first of, from an Informatica standpoint, you should think about that. That acquisition was something what we announced is the agreement to acquire Informatica. Obviously, it's going through the right regulatory approvals, etc. It is what it is. So there's not much I can talk about from an integration standpoint.
Sure.
But what I can say though is that all of these systems that have existed for the longest time, whether it's Informatica or any other relevant system that is doing data management, that is doing data repository, that do have premise-based systems, old mainframe systems, etc. All of them do have data that is relevant and that is "quote unquote" trapped, if you may, in silos. That becomes that asset, if you may, is so much richer now in the new world of providing connected experiences, what we refer to as 360 experiences, and AI, whether it's predictive or generative AI. More importantly, generative AI and the agents that go with it. So those legacy assets become that much more important in the new world of trusted AI and trusted 360 experiences.
I just have a few more questions because we're running to the end of our time, our conversation, which I've really enjoyed. I'm curious about what would you say to people out there about your technical direction, and what would you say to people out there about how they might think about their own teams and how they structure their engineering and data teams? Because what we're seeing really is uh, this idea that we've lived with DevOps for a long time, but now we're starting to see the emergence of data ops and how those teams reflect those two movements. I'm very curious about from your perspective.
Yeah, I would say come at it from a standpoint of what outcomes you desire. Let me explain what I mean by that. Today we talk about data cloud as an example, but a data cloud and agent force can be an intelligent activation engine where it's bringing the full value of your enterprise data to life. What now? Working backwards from it, right? How can data play a central role in the agentic enterprise? And the way it plays a central role in an agentic enterprise is to provide unified, trusted, and real time data as a foundation that fuels agents. If you work, then you take the next step as in saying, for that, you need fluidity of data. For that, you need fluidity so that the agents have what they need in the moment for the business use case they're trying to deliver value for. It means you need to start looking at data as in moving around in a fluid manner, in a trusted manner. So start to look at normalized protocols, start to look at normalized schema, start to look at unified data. To do that, start breaking silos, right? Think along those lines, and then your all the decisions you make at the architectural level, at the systems level, then will start to fall in place with that objective in mind.
What role does the relational database play for you then in this story? We're seeing really some new views on how to build out relational databases. For instance, Databricks talks about their capability to use agents essentially to very quickly spin up instances of databases, right? How do you view databases and their future? Maybe we can just conclude on that note.
From a databases standpoint, the way I look at it is they continue to serve the purposes in general as being the backends for transactional systems. You have an application that will continue to use databases in the backend. That's what we're seeing right now. Those databases have improved over a period of time. They know how to use structured, unstructured data. They know how to really create graphs. They become more speedy. They have become more scaled out, if you may. They're cloud based, etc. All of that evolution is working through. Now, there is also data. In some sense, think about it as being databases like the way they're fitted into applications. You're finding other data platforms like Salesforce Data Cloud, which are providing what I refer to as the lakehouse foundations, and on which we're building all this tooling, just like what other vendors are building as well, to make that data relevant for not just AI agents, but also relevant to feed it back into the transactional systems. So if you refer to Databricks as an example, we're working closely with Databricks. We're working closely with Snowflake. They are partners of ours. One thing that is evolving over a period of time here is an interesting one is that we're finding abstraction layers that allow for data to be shared across systems. So that's an evolution that we are seeing quite dramatically. We went out and we created a zero copy network, meaning Salesforce went out and created a zero copy network. Why did we do it? Because our customers asked us the ability for us to leave the data where it is, but use it for the use cases that they want to, so they don't have to move it around. In some cases, it's sensitive data. In other cases, it's for economic reasons they don't want to move it. So Databricks, for example, is now adherent to as an example, on the file layer with Iceberg. They even bought a company called Tabular to drive Iceberg-based standards. We drove, Iceberg is an open source standard, but we went out and pushed and using that for zero copy. So you'll start to see a lot more normalization, so data can be shared seamlessly across all systems, while underlying the plumbing also changes quite a bit, so that you have this concept of connectivity through the concept of graph, if you may, where you can find all touch points really driven through profiles, driven through whether the profile could be a human, the profile could be a lead, it could be an account, it could be a vehicle, it could be anything that people are really trying to attach it to. So you'll see the plumbing change, but also on top of the plumbing, you'll see quite a bit of standard interfaces so data can be exchanged seamlessly between systems.
That's really interesting. I guess my last question is, how does that reflect for you on your technical direction? And it seems like that shared capability that you're talking about with Databricks and Snowflake is part of that. What are the other core aspects of your own transformation that are important for you to consider as you're defining your technical direction over the next, 12, 18 months?
Yeah, we have talked about this concept of a deeply unified platform on which we're building our business apps, CRM, and what CRM has become now. And we're continuing to invest heavily on the deeply unified platform, whether it is the agentic foundation built on top of the deeply unified platform, data cloud inside of the deeply unified platform, deterministic flow based automation. We have this product or a service known as Flow inside of Salesforce that drives trillions and trillions of automations within our business applications. We now have Tableau. We just got Tableau Next, which is running on a semantic model that is built inside Data Cloud. That's part of the platform that allows you to have consistent semantics in an enterprise. We have Slack now that uses the same data for collaboration as well. And we have industry applications that run on top of it, on top of the platform, that allows us to understand the domain better, but uses the underlying deeply unified platform. That's the direction in which we are headed. We talked about it at last Dreamforce. We're going to talk quite a bit more about this upcoming Dreamforce on the value and the power of the deeply unified platform for being the fuel that really drives the agentic enterprise.
Rahul, thank you so much. Thank you so much for your time today. I look forward to meeting you in person at some point. I've really enjoyed our conversation.
Thank you so much. Thank you for having me on your show, and I look forward to meeting you in person as well.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.